Good morning, everybody. Today's topic is bone tissue and bone metabolism. So the topics I'll be covering is introduction, classification, development of bone, general structure of the bone, cells of bone tissue, calcification theories, mechanism of mineralization, bone remodeling, alveolar bone, and the clinical considerations. We'll consider the classification theories in the next lecture. Introduction. Bone is a specialized connective tissue characterized by a mineralized extracellular matrix. Now, the functions of the bone are shape and support to the body, which helps in resisting the mechanical stresses. It acts as a central axis of the body. The site of muscle origin and insertion are on the surface of the bone, so it provides a surface for the attachment. Locomotion by forming articulation, that are the joints which help in movement in our body. Protection of organs like the skull. The brain is enclosed in the skull and thus helps protecting the brain. Chemopoiesis, that which takes place in the bone marrow. Mineral homeostasis. Reticuloendothelial cells which take part in the immune responses of the body. And the paranasal air sinuses, which affect the timbre of the voice. Coming to the composition of the bone is made up of 67% of inorganic content and has 33% of organic material. The inorganic material are the hydroxyapatite crystals, and the organic material are again divided into 28% of collagen and 5% of non-collagenous protein. Now, the non-collagenous proteins are osteocalcin or gamma carboxyglutamate. The function of these are it acts as a chemoattractant to osteoclast precursor, that is the bone for bone resorption, and it also acts as a calcium binding protein that helps in bone calcification. Osteopontin and bone sialoprotein. Osteopontin acts as an inhibitor of hydroxyapatite crystals and mediate attachment of bone cells to bone matrix. Now, bone sialoprotein has a structure similar to osteopontin, and it helps in the initiation of mineral crystal formation. Osteonectin, which is also a calcium binding glycoprotein, it regulates the cell adhesion and proliferation and modulation of cytokine activity. Proteoglycans, they regulate fibrillogenesis, that is the formation of collagen fibers. Lysyl oxidase and tyrosine-rich acidic matrix proteins, they are critical enzyme for collagen cross-linking, and they regulate cellular responses to TGF-beta. Thrombospondin and fibronectin, they are attachment glycoprotein found in matrix of forming bone. Matrix GLA proteins and other glycoproteins help in the regulation of mineralization in bone. The other proteases, protease inhibitors, cytokines, they regulate the cell metabolism. They are secreted by the osteoblasts. IGF, PDGF, TGF, they increase the rapidity of bone formation and repair. The other BMPs like BMP2, 4, 5, 6, 7, they are all osteoinductive. The BMP2 is helps in osteoblastic differentiation. BMP3 inhibits osteogenesis, whereas other BMP14 helps in chondrogenesis and enhances the bone formation. Coming to the classification of bone, according to the Gray's Anatomy, they are classified as macroscopic and developmental in origin. Macroscopic are on the cut surface, it is compact bone and trabecular or spongy bone. And based on the developmental origin, bone can be classified as intramembranous bone and endochondral bone. Based on organization of the collagen fibers, there are woven fibered bone and parallel fiber. Based on the general microstructure of the bone, they are non-lamellar and lamellar bones. Bones classified based on region of the long bone are diaphysis, metaphysis, and epiphysis. These are the parts of the bone. Long bone. Deposition of lamellae, circumferential lamellae, osteonic lamellae, and interstitial lamellae. Based on types of osteon, the primary and secondary bone. Based on the shape of the bone, there are long bones like fibia, fibula, metacarpals, metatarsals. Short bones like carpals and tarsals. Flat bones like the skull bones, sternum, ribs, and scapula. Irregular bones like the vertebrae, facial, mandible, and pelvic bones. Pneumatic bones, which contain sinuses like maxilla, sphenoid, and ethmoid. Coming to the development of bone. Now, development of bone can be endochondral. There is a sutural bone growth and intramembranous development. We'll see each one by one. Endochondral bone formation. These are happens at the articular extremity of the mandible, long bones, vertebrae, and ribs. So endochondral bone formation is seen in these areas. What happens here is the mesenchymal cells are densely packed and then they condense. And in these condensed cells, there is differentiation of chondroblasts, which then help in the formation of cartilage. The surface mesenchymal cells form the perichondrium, and the growth of the cartilage then takes place by apophyseal growth or the interstitial growth. Now, differentiation proceeds the metaphysis, and it happens from the diaphysis towards the epiphysis, and the part in between the epiphysis and the diaphysis is called the metaphysis, which has more vasculature. Functionally, different and longitudinal zones are formed, and there is these are the zones of proliferation. Hypertrophy and maturation takes place here, and then there is zone of mineralization followed by that. So here you can see there is zone of proliferation followed by hypertrophy. These are the cells undergoing calcification, and this is the marrow cavity, bone marrow space. So there is zone of proliferation, zone of hypertrophy, and zone of calcification. This is endochondral bone formation. The calcified cartilage then disintegrates, and the chondroclasts have room for further vascular ingrowth. Perivascular mesenchymal cells accompany the invading blood vessels. They proliferate, migrate, and differentiate into osteoblasts, which again help in bone formation. The osteoid deposition takes place first, and then there is mineralization. This is how endochondral bone formation is formed. Mixture of mixed spicules is called the primary spongiosa. Osteoblasts entrapped in bone matrix are called the osteocytes. Invading vascular system forms the red bone marrow. The osteoclasts expand the marrow cavity by resorbing the inner surface of the marrow cavity. And there's an epiphyseal growth plate, which is seen at the epiphyseal end. Intramembranous bone formation. Intramembranous bone formation takes place in flat bones of the body, and like the body of the mandible, and it usually happens at the end of second month of gestation. So what happens in this is there's a soft connective tissue layer. Mesenchymal cells in this proliferate and condense. There's increase in the vasculature, and osteoblasts differentiate. Osteoid deposition first take place, and then mineralization happens in the same osteoid. This is what happens in intramembranous bone formation. The first embryonic bone is a woven bone, which has radiating spicules and trabeculae. They fuse into thin bony plates, and these plates then fuse to form a single bone. This is what happens in intramembranous bone formation. You can see the osteoid or the matrix. These are the osteocytes which are in the lacunae entrapped in the osteoid. The osteoblast lining the matrix. And this is the intramembranous bone formation. First, the osteoid is formed, and then the mineralization takes place. Sutural bone growth. At the suture, the outer layer splits. This, you can see the slide here. This is the suture, and this is the periosteum, the outermost layer of the bone. At the suture, the outer layer splits. The outermost leaf runs across the gap of the suture to form a uniting layer. So both the sides, the bone from both the sides fills the gap and helps in uniting. Innermost leaf plus the osteogenic layer of the perichondrium runs through the suture along with corresponding layer from the other bone. The osteogenic layer is called the cambium. The inner leaf is called the capsule. You can see the capsular layer here. And the cambium. The osteogenic layer, where you can see the cells, osteoblasts, is the cambium, and the inner leaf is called the capsule. This is the capsular layer. Between the cambium and the capsule, there's a loose cellular and vascular tissue. This is the loose tissue. This is called the middle layer. So the growth here occurs at the sutures. You can see here, this is the anterior fontanelle, and this is how the gap in the suture is unified. Now the general structure of the bone. Grossly, it can be divided as compact and cancellous bone. Microscopically, it can be mineralized or unmineralized bone. Unmineralized is also the osteoid, the matrix. The mineralized bone is again divided into woven bone, which is immature bone, and lamellar bone, or the mature bone. Structure of a typical long bone is diaphysis, which is the long part of the bone, the length of the bone. Then epiphysis, which is the ends of the bone, cartilaginous, which contains the cartilage, and the metaphysis. This is the metaphysis, the part between the diaphysis and the epiphyseal end. It is very rich in vasculature, and the bone growth usually happens from the center towards the epiphyseal end. So this is the metaphysis is the part towards the diaphysis. This is the medullary cavity in the center of the bone. The periosteum, the outermost layer of the bone. Endosteum is the part lining the marrow cavities. And the ends have the articular cartilage and the rich in chondroblasts. Outer surface of the bone is called the periosteum. You can see the periosteum consists of two layers again. The fibrous layer, which is the outermost layer. This is the periosteum. The outermost layer is the fibrous layer, and the inner is the cellular layer. So the two parts of the periosteum. The periosteum runs along the outer surface of the bone. Now, bone cavities, it consists of endosteum, that is the innermost cellular layer lining the bone marrow. This is the bone marrow, which contains the vasculature and the loose connective tissue. Now, in mature bone, osteons are found, osteons or Haversian system. So these are the osteons. When the bone formation takes place, it takes place in a rhythmic pattern, and in the process, the osteocytes are entrapped in it. So these cells are the osteocytes. They are present in the lacunae, and in the center, it's the Haversian canal where the blood vessels and the nerves of the bone are found. So these are concentric lamellae because they are formed in these pattern. The remnants of these concentric lamellae form the interstitial lamellae, which is the lamellae found between the two concentric lamellae. These are the osteocytes in their lacunae. They are nothing but the osteoblasts which were entrapped during the formation of bone. Now, these are concentric lamellae. This is a longitudinal section of the bone. These are the concentric lamellae with the Haversian canal in the center, which carries the blood vessels and the nerve supply of the bone. The interstitial laminae are these, which are in between the concentric laminae, and they are remnants of the previously formed laminae. The circumferential lamellae run on the inner and the outer part of the concentric lamellae. These are the circumferential lamellae. They are found in the circumference of the bone, hence the name. Volkmann's canal. These are the canals which carry the blood vessels and nerves from the endosteum and the marrow spaces to the Haversian canal. Now, bone contains the mature, the compact bone, and this is the spongy bone which contains large marrow spaces and trabeculae. Spongy bones has bone marrow cavity, and this is the compact bone which has all the lamellae. The circumferential lamellae, which is surrounded by the periosteum, again the outer fibrous and the inner cellular layer. Now the difference between mature and immature bone are, the mature bone is also known as adult bone, lamellar bone, or fine fibered bone, whereas the immature bone is known as fetal bone, non-lamellar bone, coarse fibered bone. The mature bone has an orderly arrangement, parallel running collagen, as you can see here. This is the cross section. Results in a repeated addition of uniform lamellae to the bony surface during appositional growth. Whereas here in immature bone, you can see intertwined collagen fibers oriented in any direction. These have lesser cells per unit volume, whereas immature bone have more cells. The mature bone cells have long axes in the same direction as the lamellae, whereas in immature bone, the cells are randomly arranged. Mature bone have less ground substance, whereas they have more ground substance in between the cells. Now, mature bone forms less rapidly. Mature bones form more rapidly. Mature bone is rich in osteocalcin, whereas immature bone is rich in bone acidic glycoprotein and BSP. The mineral density is high in mature bone and the water content is low, whereas in immature bone, the mineral density is low and the water content is high. Mature bone stains with eosin because it has less ground substance, whereas immature bone stains with hematoxylin because it has more ground substance and proteoglycans. Coming to the cells of the bone tissue, various cells found in the bone tissue are osteoprogenitor cells, osteoblasts, osteocytes, bone lining cells, and the osteoclasts. Now, the stromal stem cells, they form the osteoprogenitor cells, which are the precursor cells. The osteoprogenitor cells forms the pre-osteoblast, which then forms the osteoblast, which then form the osteocyte and the lining cells. Now, coming to the osteoprogenitor cells, which are the precursor cells, they are located in the inner layer of the periosteum. As I said, periosteum has a fibrous and a cellular layer. The endosteal cells have osteoprogenitor cells. The Haversian canal and the Volkmann canal have osteoprogenitor cells. They appear as flattened squamous cells. They have lightly stapling, elongated or oval nuclei, and they are inconspicuous, acidic, slightly basophilic cytoplasm. These are the osteoprogenitor cells. Osteoblast. Osteoblast secretes type 1 collagen and the bone matrix proteins, that is the calcium binding proteins, multi-additive glycoproteins, proteoglycans, and alkaline phosphatides. These help in the formation of bone. So the appearance is they are cuboidal in shape or polygonal, in apopposition to forming bone, they are found close to the bone formation. They are basophilic cytoplasm. And when inactive, they are seen as flat cells resembling the osteoprogenitive cells. These are the osteoblasts. You can see polygonal shaped cells formed around the new bone formation. Osteocyte. The function of osteocyte is to maintain the bone matrix. Mechanotransduction, synthesize new matrix plus matrix degradation, which helps in calcium homeostasis. They reduce the load on the bone, secrete matrix metalloproteinases for enzymatic degradation of the collagen. And then thus the degradation of the bone takes place, and this is called as osteocytic osteolysis. The appearance, these are the osteocytes. They occupy a space called a lacunae. They are the entrapped cells. Cytoplasmic processes or canaliculi contact the neighboring osteocytes and bone lining cells by gap junctions. Smaller than precursor cells because of the reduced perinuclear cytoplasm, they appear smaller. And they have less cytoplasmic basophilia than osteoblasts. The bone lining cells. The location of the bone lining cells are, they are found on the external bone surface, the periosteal cells, the cellular part of the periosteum, and the lining the internal bone surfaces, that is in the endosteal cells. The function is to maintain maintenance and nutrition support of the osteocytes. They regulate the movement of calcium and phosphate in and out of the bone. Appearance, they appear as flat cells. They have attenuated cytoplasm and paucity of organelles beyond the perinuclear region. These are the bone lining cells. This is the blood vessel, and these are the bone lining cells. Osteoclast. So the origin of the osteoclast is from the hematopoietic stem cell, which then forms the osteoclast progenitor, which then differentiates into a pre-osteoclast, which then forms an inactive osteoclast and a multinucleated osteoclast. Now, macrophage colony stimulating factors, trap and rank, receptor activator of nuclear factor. These are the important enzymes which are required in the formation of osteoclast. The appearance of osteoclast is they appear as large multinucleated cells. They have marked acidophilia. Resorption or Hoship's lacunae are found immediately under it. And they have a ruffled border in direct contact with the bone. Here you can see the structure of an osteoclast. This is the ruffled border. This is the resorption pit or the Hoship's lacunae. It has a clear zone running all along over the ruffled border, which helps in maintaining a tight seal so that the acidic environment here can be maintained. This is the clear zone, which contains actin filaments and muscular filaments. This is the basolateral membrane. And this part is the secretory domain from where the digested material is exocytosed. Now, these are the chloride channels and hydrogen channels which are present here. The hydrogen ions and the chloride ions are secreted in the resorption bay or the Hoship's lacunae. Also, the matrix metalloproteinases and cathepsin K helps in digestion of the collagen fiber here and causes the resorption of the bone. This is the mechanism that helps takes place in the osteoclast. With the help of carbonic anhydrase, the hydrogen ions are finally released. The chloride ions come in and are secreted in the resorption bay. The hydrogen ions are secreted in the resorption bay. This clear zone helps, the muscle fibers here help in maintaining the tight seal here. And whatever the resorbed bone is ingested is then exocytosed. So this is the end of the bone structure. The calcification theories we will be taking in the next lecture. Thank you for now.